Hello, prop sets, and I hope you did well on sections 2.1 and 2.2. And today we're going to do 2.3. So now we're going to be doing graphs that enlighten and graphs that deceive. So when am I lying to you, or when are you lying to me? So make sure you've got your notes out, you're ready to go, and let's have some fun with this. All right, we're going to be using different types of things. We're going to do a dot plot, a stem plot, a time series graph, and a Pareto graph, along with a pie chart and a frequency polygon. And then you have to tell me if I'm lying or not lying to you. So let's go here. First is the dot plot. In the dot plot, I know a lot of these you've seen when you were younger, so this hopefully is just a refresher. But a dot plot is really nice because it gives you can reconstruct your data just by looking at it. So in a dot plot, you have every data value on the bottom. So we're going to go from 40 to 110. And the dots above represent those numbers. So if you look here, we're going from 40 to 50, right? So I'm going by twos when you look at this. And I can look at this and say, hey, I had a 40. And then this dot right here represents 42. I had nothing until I had 50, and I had two of those because there's two dots above 50. Then you look, we have 52 and we have 5 dots. See how I can reconstruct my data, which is really nice. And this will go on until you get to the end of your data over here. It also gives you a general shape of your data. So if we look at it, it looks like it's evenly distributed, which is really nice. It tells us exactly where everything is. It's a very informational graph, what we like. So dot plot, you just have your lines and every dot represents a number, and that's about all there is to that one. Okay, now let's look at stem plot, or a stem and leaf is what I think you called them when you were younger. Okay, it still shows you the general distribution, but now you're looking at it sideways. Like here's your line, and you're looking at it going like this. All right, so when you look at this one, it starts low, it goes up, and oh, that's terrible drawing, but it does look like a nice little bell curve, which we like. Okay, we still have the original data, just like our dot plot, and they're sorted really easy for us. So when we look at this, this is the 4 where we're starting. So my first data is 40 or 40, like we had before. Our next point is 42, like we had before. Then we continue. I have two 50s. And if you look, we then have 5 52s. It's the same data set, just arranged differently. And we could go on forever. But it puts them in nice order for us. It shows us where everything's showing up. We can see here we have most of our data in the 60 range, and it's a good visual. It's what we like to use. Okay, I want you to use your survey question. Okay, not two, I think it's actually the third one, to create a dot plot and a stem plot. And they are a little bit time consuming, so make sure you take your time and you do them well. All right, a time series graphs shows you how things change over time, like at different points in time. It can be monthly, it can be yearly, it can be daily. Like if you graphed COVID, that was on a daily basis. So on a day, we could graph where our percentages were. That would be a time series graph. All right, this one here is to do with farmland. And I wanted to show you what it did. So like in 1950, it gave you a value 60, 70, 80. We had a nice little peak, but then it dropped back down, and then we got 90, 2000, 2010. This year is probably 2020 or 15. Can't see real well. And we had a peak, and then it fell again. All right, so this shows you what's happening over time. Now, if you look and you draw a nice curve to represent this graph, it looks like an exponential growth. It's probably going to level out at sometimes because there's no way money can go on forever, so it's not quite an exponential growth. But from what we can see, that's what it looks like. So it gives us information. We do know it's not a straight line, which is really important for the rest of our data. Okay, a bar graph. Now, it's very similar to a frequency, all right? So it shows frequency of the category, or we can also do it by categories, like how many people like Iowa, then Iowa State, then Nebraska, and then that type of thing. The bars may or may not be separated by small gaps. It doesn't matter. The one thing to do recognize is it does not include your boundaries like our frequency chart did. All right, so when we look here, in 2008, we had 115, then 117, then 132, 29, 27. It looks like we got just a nice general increase and then back down. But now be careful. Did my graph lie to you? Are you looking? Where's the lie? I hope you found a couple. All right, so this here was just to show you how to do those graphs, but look at here. This is what's coming up. This starts at 100,000, all right, and then it goes by 10,000s. I am missing the entire lower half of my graph, which makes these lines look a lot less far apart when you look at it. Because right now, this looks like this is a huge difference between here and here. But when I fill these in, does that look like it's such a big difference? It's not near as much, right? The gap isn't as big. So this is a deceptive graph. The other thing you need to look at is I lied to you down here. We went from 2008, I think is what that says, or 6, 2009 to 2012, 13, and 14. These are 1 year apart. This one here, if it's 8 to 9, is 1 year apart. But what happened to 10 and 11? Interesting, right? So again, another lie. So make sure you're being careful when you read your stuff. Even though it does represent your bar graph well. I mean, it shows you what a bar graph looks like, but we have a deceptive bar graph in this type. I hope you noticed that. Okay, Pareto graph. When you look at this guy, it's really cool. All right, so we do these here graphs are categorical. All right, so it's not going in an order of any type. Like I don't have years on the bottom. Those are not allowed. I would not have an age on the bottom. That would be not allowed. I wouldn't have dollars on the bottom because money would go up. Those type of things are not allowed. These are things I can do in categories. So here I have jet skis, motorboats, fishing boats, inboard boats, and sailboat. And we always order them from our highest, so this is the most, to the least. So when we look at this guy, this is talking about things that are stolen. Jet skis are stolen the most. And then next are your motorboats, and then your fishing boats, and then your inboard boats, and then your sailboats. Probably because they're the hardest to steal, and these are the easiest, would be my guess. But when you look at it, that's a Pareto graph. It shows you how it goes. And it always starts highest to lowest requirement. Now, did this graph lie to you? I hope you said no, because look, it starts at 0. It's going up by 200 increments. There is nothing falsified on this graph. These bars actually show what they're meant to show. Okay, a pie chart. This one you have been used to forever. Again, this one here, without the percentages, which would be better, it shows you who's the most and who's the least. Again, easily, jet skis are stolen the most and sailboats are the least, and by a large amount. That's a very quick representation, usually what bosses like because they're easy to read. Now, a frequency polygon. All right, a polygon is, our frequency polygon is actually very easy, and you've already graphed these. Because what we do is we take the midpoint values of our charts. So we're going to look at a histogram. All right, so you look at the histogram that you've already drawn, then you find the midpoints of all of those values. So my midpoint is here, here, here. You're looking at the C, so the middle from here to here, the middle of D, and the middle of E, and then you go back down to the middle of where F would be, and you just connect them. So the red line is actually your frequency polygon. It's always created from the histogram. All right, did this one lie? I hope you came up with the answer of yes, because it does not start at 0. When you look here, oh, actually it does, I'm sorry. It goes from 0 to 20 to 40 to 60 to 80. Here it starts from 35 to this. Okay, I'm going to change my name. The answer is no, it does not lie to you because it starts at 0 This break here makes no difference as long as there's no outliers over there. And we draw it in. It's a nice little graph, no lies. All right, look at these two. Now, why is it lying? And which one is lying? Okay, I hope you realize the difference was here. This one starts at 10 and goes by 2%. So I'm missing the bottom 10%. This one is nice, it starts by 0. Increments are evil. These two bars represent both of those beautifully. This one does not. It makes it look like this is a huge difference, when in actuality it's not that much. Okay, I hope you get it. They're kind of cool. All right, the next one we have to look at are pictographs. Yeah, that's when we use images, which is nice when you want to look at something, like aesthetically it's pleasing, but you have to be careful. All right, so usually like on a one-dimensional thing, if we use a dollar bill, like say if I say this dollar bill, all right, and then I'm going to say it's doubled. So I'm going to double both the height and the length. Well, if I double both the height and the length, how many of these dollars fit into here? And I hope you came up with 4 of them. So this is 4 times larger than this one, but I said it only doubled. So the pictures themselves are deceiving. All right, I have lied to you without meaning, well, maybe with meaning to, but hopefully without meaning to. Again, look at your pictures of your smokers. I doubled this guy, so this guy is now double this, and the length is doubled. This is 2 times, but I can fit 4 of these into here. So this is actually 4 times the size. It is lying to you. Pictographs are very, very hard to make that don't lie, because when you double something, in order to keep the proportion, you must do the other to make it look right. So it's a little bit more difficult. So to get double, you would have to see what the times this guy by the area by 2, which would just be a little higher and a little wider. And then you'd be good. Or if you kept the width and just doubled the length, that would work also. But you can't double both. All right, good luck on your homework. I hope you do well, and we'll see you later.